get 15 of those. Once you get up to 15, switch to the next buffer. Once you get that 15 done, switch to the next buffer. And then you're done. Now, how are we going to tell which of these guys has an amino acid? We don't have any fluorescent material. So this is where we have to use chemistry. And the chemistry we're going to be using is ninhydrin. It's this handy-dandy little guy, little aromatic ring connected to a 5-member ring. 5-member ring has a couple of carbonyls and a couple of OHs. What this guy wants to do is attack amines. So this will attack a free amine on any amino acid. It will release carbon dioxide. It will release this guy as an aldehyde, and it will release the ninhydrin with an NH on, NH2. Now, if you've got your book, your manual, it actually has a mistake. It has that structure wrong. It doesn't have that NH. And then what this guy does is, since that ninhydrin likes to react with these NHs, the second ninhydrin will say, hold it, there's an NH group there that I can react with. So a second ninhydrin comes and tries to react with that NH. And it can't do the same exact reaction. What it will do is hook 2 of these guys together. And once it hooks these two guys together, you've got this wonderful aromatic system where we can go from there to there to there to there to there. Big aromatic system, big strong absorbance, and this guy has a deep purple color depending. Usually it's deep purple. Now, this reacts with any free amino acid. And, okay, now the first question that I have for you is on your first question for today. Will the reaction with BSA be the same or different than the reaction with the amino acid? And the reason I'm asking this is I want to see, did anybody find in the manual there any reference to that question? Because I'm not sure whether it was a fair question or not.
No, it wasn't.
There wasn't a reference. And the proper answer here is supposed to be that the BSA should not react as much. And that's because BSA is a protein, and a protein is made up of amino acids. So that part's good. But when you're making up a protein, you've got one NH3 plus at one end, you've got an amino acid, and that amino acid is hooked to the next amino acid to that linkage. What did we call that linkage a couple days ago? Peptide bond or an amide. And an amide doesn't react with ninhydrin. It's not free, so it can't do this. So the proper answer there is supposed to be that the protein does not react as well because it's got some NHs, but they're mostly tied up in that amide bond and they shouldn't react. We'll have to see how today's data goes. Last year it seemed to react just as well with amino acid. So I don't know what's going on there. But in theory, it's not supposed to react nearly as well. And okay, so up here is this blue one, a set of lots of the individual amino acids, and I have 5 different sets, so you can spread them out a little bit. On this one, we've only got our choice of 3 different unknowns, A, B, or C, and this guy over here is the BSA sample. Now the other thing about that ninhydrin reaction, where else would you find amines or amino acids in today's lab? On your body, on your skin. So the way you're going to do that reaction is over here in the liquid. It's a little bit stinky. The solvent it's in is an organic solvent. what we'll do is just pour it in this Tresemme, bring it over here. What you're going to be doing is, with this guy, do all 15 of your samples at once. What you can do is grab one of these pieces of filter paper and just put a drop or two from each sample kind of in a circle all around the outside. 1, 2, 3, 4, 5, 6, 7. And when you get all 15 fractions on there, you take it over there in the hood and you simply spray it with an inhaler. Okay? But we just said that this reacts with any protein, any free amino acid, and your hand's got them all over. So unless you want to have a purple hand by the end of the day, wear gloves and hold it with this guy. You don't have to get this guy totally soaked. You should just get a nice clean spray, but don't get it soaking so it's sopping and falling apart. Once you get that part done, the reaction itself takes a little bit of heat. So you come over here, put this guy on hot, and you heat it up until you get a reaction. Okay, so we got a couple tongs there, a couple more tongs over here. I think that's everything. Anybody have any questions? Okay, get your goggles on and let's get started.